Minecraft does not always run as smoothly as we want it to, especially with high render distances, large worlds, or demanding graphics settings. Getting stable performance can become difficult. If you are using an Nvidia graphics card, you might have heard about Nvidium. It is a mod designed to improve rendering performance and increase your FPS by using newer GPU features more efficiently. But there's one big question. Why does Nvidia not work together with Minecraft shaders? To understand that, we first need to understand how Minecraft normally sends information from the CPU to the GPU and how the GPU turns that information into the final image. To explain it in an understandable way, I will guide you through a 3-step process, very quickly but still understandable. And we begin with the CPU doing its work. The CPU handles all the preparation for the GPU. We have multiple passes. First, OBQ objects. They are solid and cannot have alpha values in their textures. Then, transparent objects. First, we handle shadow mapping. To simplify it, it's a projection from the light source's perspective. Finally, we have light information to finalize the screen. Everything is handled through a strict sorting machine. Before that, we need to create resources to be handled and a root signature to define descriptor tables. Those are slots used to bind data like textures to an object. So next, CPU sorts everything. We can finally assign all data to every object and then the rendering starts. While rendering, every pixel on the screen is drawn by the GPU. Now, for instance, we create a world. The sorting machine handles render passes with multiple types of data, like 6 solid objects, 3 transparent objects, 6 shadows for those 6 solid objects, and 18 light sources. Let me start the sorting machine. Every render pass goes through these hoppers down into the chests. They get prepared for the rendering on the GPU. Solid, alpha, shadow, and light data are going through. Now we wait for the CPU to finalize every piece of data. Of course, it is much faster than this dropper. We can now see light data getting into this chest. And okay, seems like everything is done. Yeah, I turn it off now. And when we look into every chest, we can see every object has been sorted into its correct place. Okay, we can now move on to the GPU section. And it is basically the combination of all data to create a final image. For instance, OBQ objects, we expect the following resources. Programmers start counting with 0 instead of 1. Slot 0 expects a texture, an image applied to a block. Slot 1 expects the position of the object in this world. Like we can see on this map, this position marker is important. Slot 2 expects the material data for custom colors and values like roughness or metallic. It is basically used for realistic or custom visualization. Finally, slot 3 expects the camera view, like me looking at the sign. The result is a correct render of the world and its objects. And every slot is a descriptor table, like I previously stated, created through the root signature. And every slot is a descriptor. Now, as an example, we take a transparent object but use the wrong resources for every slot. Slot 0 expects a texture, but we use a position instead. You would see something like a rainbow object instead of the expected visualization. Slot 1 we expect a position, but we leave it empty. The data becomes invalid, which would already break everything at this point. Slot 2, the GPU expects material data, but we assign the camera view, leading again to completely wrong colors. Finally, slot 3. We expect the camera view at this point, but we use light data, and you know what it means. The result: we see a broken render because the GPU doesn't know which resources belong to which slot. This means invalid values lead to incorrect visualizations. So the correct order should always match how you defined every slot inside your root signature. But why am I even explaining this to you? Let me now answer why Nvidium will not make shaders work. Everything I just explained is the current system used by Minecraft. Nvidium changes the entire approach. The way CPU and GPU communicate is fundamentally different. Like I explained, Sodium and Minecraft shaders handle every single object individually. Every object gets calculated separately, and this is not really efficient. In this chest we see a solid object with all its data bound. Your computer would need to process these bound resources many times. Every render pass multiplied by every object. A lot of work. But now let's talk about Nvidium. It allows the shaded system to work with a complete scene, not just a single object, but all objects inside a render pass. And this leads to the main problem with Nvidium. All shaders available on the internet would need an update to work with this new system. Because like I said, the entire rendering approach has changed. We would need to rewrite how the CPU and GPU communicate. All shaders still calculate every object individually, so they expect many descriptor tables for each object. Nvidium expects the scene itself. Big difference. So that is the reason why Nvidium and traditional Minecraft shaders are not simply compatible. Nvidium is not just a small optimization, it changes the way Minecraft communicates with the GPU and how the scene is processed. Shaders are built around the existing rendering system, while Nvidium uses a different approach. Hopefully this helps you understand what is happening behind the scenes and why combining these technologies is much more complicated than just adding shader support. Thanks for watching and see you next time.